Hello, Martin, Rida, Hamna. Yes. Okay, so all of you, first of all, tell me about your upcoming exams, right? Okay, Hamna, so when are you having your next exam? Yes, Rida, what about you?
The dates are not decided, but I think 2 weeks later.
2 weeks later, I think mid of January, I guess, around.
Yeah,
So this will be your first pre-board or second?
first.
First, okay. What about you, Martin?
Yeah,
Any
mine's on January 9th.
9th January, they're starting. Pre-boards, right? Full syllabus.
Yeah.
Hamna, what about your exams? Yeah, please unmute yourself, Hamna. Okay, any chapter you think you want to do revision? Tell me that. Rida, any particular chapter you're facing problem?
No, ma'am.
No. Okay. Martin, what about you?
Let me check.
Sorry,
Let me check.
I'm not able to understand, Martin. Which chapter you are saying?
Let me check.
Okay, okay.
The surface area.
Surface area and volumes. Okay. Okay, let's do some revision today of surface area and volume. And in the next class, I will be taking a test of this chapter. Clear?
Oh,
Next means
okay.
today is 27th, so it will be 29th of December. Surface area and volume. So let's do some questions which were previously asked in CBSE exam from this chapter today. We will try to solve it together. Okay, let us quickly revise the formula which were used in this chapter. So basically the shapes you studied here were cuboid, right? And then you have
Yeah.
cube. Okay. Then there was right circular cylinder. And then you also have right circular cone, and then sphere and hemisphere also, just half of it, right? Hemisphere. And also the spherical shell. So shell means nothing that you have two radii. Basically, one is the outer radii, one is the inner radii. So if you subtract the area, so you get this area, right? Or if you subtract the volume, so you get the volume of this shell. So it's nothing new. You have to use the sphere formula here. Okay. So if you remember, like cuboid, so surface area, that means total surface area. What was that, Martin? Can you tell me?
Yes, Cuba is
Yeah, so 2 into
2 into
LP
LP.
plus pH plus HL, right? And if you want to find only the lateral surface area. Okay, anyway, forget it. So volume is, what is the volume of cuboid? Simple, length into breadth into height, right? Okay. And then you have right circular cylinder. Okay, cube, you know, all the length are same, so it will be L cube only, the volume, right?
Yeah.
Okay. Now cylinder. So total surface area, or you write curved surface area of a cylinder. Curved surface area means only the curved part. So 2 pi r into h. And if you want to find the total surface area, so that means the curved surface area plus the area of the top plus the area of the bottom. Understand? This is the total
Yeah.
surface area. Okay. And what about the volume? Volume was 1 upon, no, pi r square into h. Now you come to cone. So again, the curved surface area, if you want to find. Yeah, what is the curved surface area of a cone? Remember that? Pi r into L. L is the
And
slant height, right? This one, pi r.
yeah,
Now total surface area, that means the curved
higher
slope.
plus
Yeah, and the base, pi r square. And then you have the volume, which is 1/3 of cylinder. So 1 upon 3 pi r square h. So the, right? Okay. Now sphere. So in this case, total surface area, curved surface area is the same thing, which is how much? 4 pi r square. And volume is 4 upon 3 pi r cube. Clear? Okay. Now hemisphere is hemisphere. So if you want to find curved surface area only, so this will be half of a sphere, 2 pi r square. But if you want to find the total surface area, so it will be curved surface area plus the area of the top. Again, 1 more pi r square. So that becomes 3 pi r square. Remember? Okay. Now volume is just half of a sphere. So it becomes 2 by 3 pi r cube. Fine, Rita?
Yes, ma'am.
Okay. Now let me give you few questions which came in CBSE previously. Let us solve it. Yeah, NCRT questions are also important from this chapter. So this came in CBSE 2010, right? Sorry, 2010. The rainwater from a roof of 22 meter into 20 meter drains into a cylindrical vessel having diameter of base 2 meter and height 3.5 meter. Okay. If the vessel is just full, find the rainfall in centimeter. Yes, Martin. Written.
Yeah, writing.
Yes, Rida. Written.
Yes, ma'am.
Okay. Now see here, this question is not tough. Now see what is happening here. That the rainwater from a roof. So there's a roof, Martin. Let's say the roof is like this, right? Whose dimensions
Yeah,
are this? So this is 22 meter and 20 meter this side. Only two dimensions are given. Okay. Drains into cylindrical vessel having a diameter of base and this. So basically the rain water is collected on this roof. Understand? Now this water, so from some drain, it is falling into a cylindrical vessel. So for this cylindrical vessel, diameter of base is given. So this diameter is 2 meter and the height of this is also given, which is 3.5 meter. So you can easily find its volume, right? Okay. Now, how much water is coming into this cylinder? Because it's a three-dimensional figure, so you also need a cuboid here, right? You have to find the rain in centimeter. Let's say rainwater is collected up to some height. This height is x centimeter. Is that clear? Or x meter? Okay, everything is given in meter in the question. Yeah. So later we will convert it into centimeter. X meter. Clear, Martin?
yeah,
So
ma'am.
if the height of the rainwater is x meter, so it will become a cuboid. Yes, Reda?
Yeah,
So basically, you will find the volume of this cuboid now, whose length is 22, breadth is 20, and the height is x.
how do you know it's a cuboid?
It's a cuboid because this is given length into breadth, which is rectangle, isn't it? And
Yeah, ma'am.
if you also add height to it, so rectangle will convert into a cuboid. That's why. Now,
Okay.
now the rain which is collected in this volume is actually transferring into this. And if the vessel is just full, that means exactly filling. That means these two volume are same, equal. Yes.
Yeah, ma'am.
Yeah. So we have to basically equate the two volume in this question. I hope you understand the question now. So first let us come to cylinder because everything is given here. So for this cylinder, how much is the diameter? Which is 2 meter. So that implies your radius is 1 meter, right? Now height is also
Yeah,
given,
ma'am.
which is 3.5 meter. So you find its volume. So volume of cylindrical vessel. Now this we know pi r square into h, clear? So you can 22 by 7 into radius is 1 meter. So 1 meter into 1 meter and height is 3.5 meter. So if you remove the decimal, it will be 22 divided by 7 into, okay, 1 into 1 is 1 and it will be 35 divided by 10 and then meter square, right? Now 7 into 5 is 35. So it will be just 5 into 22. So 5 into 2 is 10. Carry 1. 5 into 2 is 10 and 1, 11. 110 divided by 10 meter square. So which is 11 meter square. Oh, sorry, cube. Yeah, because 3 m are there. So cube, not square. This is volume, meter cube.
Okay.
So volume of cylindrical vessel we have found. Okay. Now let us assume that the height of the rainfall, or we can say let the rain is let the rainfall be x meter. I mean the meaning of it that when the water is collected, the height is x meter. Understand? Okay.
Yeah, ma'am.
So how much is the volume of water which will be collected?
11.
So that means the volume of sorry, that means it is now the volume of cuboid, right? Having you can say having base this 22 meter into 20 meter which is given in the question, and height x meter. Understand? This will be the amount of water. Is that clear? The amount of water is nothing but it will be same as the volume of cuboid. So cuboid is actually like this, whose base is this 22 meter into 20 meter, and the height is x meter. So this is the amount of volume which this will be the volume of water which is collected here. So that means volume of cuboid is 22 meter into 20 meter into x meter. Right, Martin?
Yeah, ma'am.
Okay. Uh, so how much is the volume of
7.
yeah, so this is the volume of water, right? Now this volume of water is same as the volume of the cylinder. Yeah, because the cylinder is just full, isn't it?
Yes, ma'am.
Okay. As the cylinder is just full. So therefore, volume of water is same as the volume of cylinder, right?
Yeah, ma'am.
Okay, so this volume of water is this 22 meter into 20 meter into x meter. And volume of cylinder we have already found, which is 11 meter cube. Yeah. Okay. So from here you can find your x. So x will be uh, sorry, 1 minute. Yeah, sorry. Okay, right. So x will be how much? 11 and divided by 22 into 20. And 1 meter will come here because it is height, it will be in meter. Clear, Martin?
Yes,
Okay.
ma'am.
So, okay, so 11 into 1, 11 into 2 is 22. So this is 1 upon 40 meter, right? Now you have to convert this into centimeter. So I think I have told you milli, centi, deci, meter, deca, hectare, kilo. Yeah. Now you are going from
Yes,
meter
ma'am.
to centimeter. So you are here, right? Now you want to go to centimeter. So one place 2 place. So 2 0 you will multiply. Understand? So 1 upon 40 into 100. Now this is in centimeter. Why you are multiplying? Because you are going towards a smaller unit. So you will multiply. Okay? Centimeter is smaller than meter. Okay, so 1 0 cancel out. It is just 10 upon 4 centimeter, which you can easily divide. So 4 into 2 is 8. It will become 20. So 2.5 centimeter. This is the rainfall in centimeter. Okay, I hope you understand this. Now,
Yeah.
one more question I'm giving you. A well with 10 meter inside diameter is dug 14 meter deep. Yes, written. Yeah, Martin, written.
No, I'm writing.
Rida.
Yes, ma'am.
See, again, it's not a tough question. See here. This came in 2016, right? Okay, so a well with 10 meter inside diameter is dug 14 meter deep. So you all know how a well looks like. So from the top, it looks like this, whose diameter is given. So this
Each taken out of it, it was written them.
earth taken out, earth or soil, you can say, right? Earth taken out of it. Now, see here, Martin. A well with 10 meter inside diameter. So this diameter is 10 meter, is dug 14 meter deep. So that's the depth of the well. Earth taken out of it is spread all around to a width of 5 meter to form an embankment. So whatever soil is taken out, it is spread around this well like this. Right, Martin?
Yeah, ma'am.
Okay. So this width of this embankment is 5 meter. Find the height of the embankment. So obviously, it it is like this, right? It is having some height also.
Yeah, ma'am.
So you have to find the height of this embankment.
Whole thing?
See, this is a well, right? You are
Okay.
you are digging a well in a earth. So obviously a hole will be created and some soil will come out, right?
Yeah, ma'am.
Now that soil is actually spread around this well. So the width of this embankment is will be 5 meter. You have to find its height also.
Okay, ma'am.
See, it will look something like this, Martin. For example, inside you have a well and then a little height is formed around this well like this, right? This is your ground.
Yeah, ma'am.
Yeah, it's something like that. Okay. So what is happening here in this question? See, the volume of cylinder. Well is in the shape of cylinder, right? Is equal
Yeah, ma'am.
to is equal to the volume of this embankment, isn't it? Obviously, that's the same soil which is coming out. Clear?
Yeah,
Now,
ma'am.
now this embankment is actually a shell, right? So shell means mm, see, how does it look like? It looks like this, Martin. It although it is also in a shape of cylinder, but the height is quite less. Is that clear?
Yes, ma'am.
Yeah. So and it is of this shape, right? So basically, if you want to find this, so you have to find the outer volume of outer cylinder minus the volume of inner cylinder. Understand? Yeah.
Yeah, ma'am.
Okay. Oh, so how can you write it down? So volume of earth dug out, right? Or taken out is actually equal to volume of embankment in this question. Clear?
Yeah, ma'am.
Okay. So if I again draw a figure, so this is your well whose diameter is 10 meter. And then you have embankment whose width is 5 meter. So obviously your outer radius from here to here, or you can say your outer diameter will be 10 plus 5 plus 5. Isn't it? 5 this side and 5 this side. So outer
Yeah, ma'am.
diameter is 20 and inner diameter is 10. Understood?
I was like deep, right? 10-meter deep.
Deep is 14 meter. Read in the question. Dug 14 meter deep.
Okay.
Yeah. So outer radius, which I'm denoting by capital R, sorry, outer diameter, you can say, first of all, outer diameter is 10 plus 5 plus 5. So that is 20 meter, right? And inner diameter, it is given in the question, which is 10 meter. So from here, you can write that outer radius, which we are denoting by capital R. So it will be 20 by 2, which is 10 meter. And inner radius, which I am denoting by small r, this is 10 by 2, which is 5 meter. Clear? Okay. So first of all, let us find this left hand side, volume of earth dug out. So this is pi r square h, isn't it, Martin? Cylinder.
Yeah.
So 22 divided by 7. And inner radius, because this is well, inner is actually well. So we are using the diameter of the well here, or the radius of the well. So this is 5 meter into 5 meter, and height is 14 meter. Clear? Depth of the
Yeah,
well.
ma'am.
All right. Now this is simple. So 7 into 2, 14, that you can cancel. 2 into 22. Okay, so you are getting 22 into 5 into 5, and then one more 2 here, and then meter cube. So you can multiply it like this, these two together and these two together. So 5 into 2, 10, carry 1, 5 into 2, 10, and 1, 11. And this is again 10 meter cube. So this becomes 1100 meter cube. Right? Okay, now come to embankment. Okay, let us assume some height. Let capital H be the height of embankment. Small h was for cylinder, capital H for embankment.